All right, this is our applied project final report. I'm Carter. We also have Carson and Beth Ann,
Hello.
Hello.
and we are Bot Sentinel, Group 6. So, what is a bot? It's an application that does something on the internet. It can be fully or semi automated. Social media has been bombarded with bot activity, and our project is meant to reasonably identify accounts that have bot like behavior. Our problem statement is to use machine learning models learned in this class to accurately predict whether or not a Twitter account is a bot or human. Current solution out there is Botometer, and this uses a machine learning model that gives accounts a score based on their activity. A higher score equates to a higher likelihood of being a bot and vice versa. For our data, we use Botometer's datasets. They consist of accounts that are verified by Twitter as being human or accounts that self-identify as being bots. And we will use this set to train our own model. This set has 750 bot users and 2,000 real users. For each user, we could take the 20 most recent tweets, and we looked at if there were repeats in times when they updated their status, the variance in minutes and seconds of these statuses, and the percentage of unique words in the status, excluding the top 10 most common words found on Twitter. For the data, we learned that most of it was not being read due to a rate limit, and that many of the accounts no longer existed and could not be accessed. We fix this by applying tweepy methods which wait for the rate limit to go down before getting tweets and skipping over dead accounts. And this really helped our score, and we also split this data into training and testing data.
The data graphs reflect two different things. The first one being repeats and the variance. The humans are in a cluster of purple, while the bots are often spread out more, but do reside inside that cluster. The bottom graph has the repeats and then the uniqueness. Here, the bots are actually throughout the entire graph, while humans are more closely compact. Note that there still exist some bots within the cluster of humans, though. For our machine learning solution, we used for features the aforementioned data, and we trained our model using this data as a subset, doing the test train split. We implemented k-neighbors classifier as a model and used grid search CV to determine the best parameters. Next, we used calibrated classifier CV to get better probability predictions as well. For the classification, we used the classification report, and we found an F1 score predicting humans as 0.96 and an F1 score for bots as 0.85, with an accuracy of 0.93. Then we evaluated our probabilities and found a mean squared error of about 6%, and the full figure is reflected below. Next, we wanted to look at real accounts that we know aren't bots and give them a rating and kind of compare our rating with Botometer to see how well we were doing. Here's the rock being shown to have a probability of being a human of 96.1%. The same thing is reflected with Botometers as well, as it gives a low score.
We also compared the POTUS Twitter account, and our model actually seemed to predict it better because it predicted that there was a 96% chance it was a human, while Botometer predicted that it was about a 50% chance it was human. This account was interesting because we know it's a bot, but both Botometer and our model had a difficult time predicting that it was a bot and assumed it was a human because this is a unique bot because people will send it tweets and then it will respond in real time with including words that the human initially tweeted at the account. We also compared it to this self-declared account that tweets Hoser lyrics, and we were happy to see that they both accurately predicted with a very high probability that the account was a bot. As for our results, we learned how to interact with Twitter's API using TweetPy. We applied and received a Twitter developer account. We downloaded and filtered data from Botometer datasets using a pandas data frame. We created a preliminary model using KNN. We optimized the model using grid search CV and calibrated classifier CV. And we evaluated the model based on classification report and mean squared error. In conclusion, we achieved being able to identify the probability of whether or not an account is a bot. Originally, we wanted to be able to say, definitively whether or not the Twitter account was a bot, but it is difficult to be 100% sure, even as a human checking the Twitter account. But we were able to achieve relatively high F1 scores, which reflects the model made fairly accurate predictions. And we had relatively low error. Something we could have done different was use natural language processing to process the text data, because bots are known for having saying things that sound like phishing emails where the syntax and the tense might just be off. Something else we could add in the future is have more interpretability like botometers so that the person could know more about why the account is being predicted as either a human or a bot. And then more features could be added, such as use of location, because bots are known to be posting from similar locations or the same location.